Hello, students of grade 8. We are continuing now or this week what we started last week, lecture 8, remarkable identities. Last week we talked about expanding. This week we'll talk about factorization. What are the objectives of our lesson? Let us start. Objective number 1, factorize an algebraic expression by finding a common factor. Objective number 2, factorize an algebraic expression using remarkable identities. Number 1, how can I factorize an algebraic expression? What do we mean factorize? To factorize is to take a common factor between the monomials of the algebraic expression. After that, I open parentheses. Then I divide each term or each monomial by the common factor and I write the answer of each division. The common factor between the terms of an algebraic expression might be. So what can the common factor be? It can be a sign, it can be a number or a coefficient, a sign and a number. It can be a variable, a monomial, or a binomial. So I will have this form, which we call the expanded form without parentheses. After I factorize, I get the factorized form, an algebraic expression with parentheses. Let us solve these examples. A equal 42 minus 6x. So first I should find, or I ask, how many terms do I have in this algebraic expressions? 2. 42 is the first term and minus 6x is the second term. To find a common factor, I asked, here I have the sign positive and here I have it negative. Is there any common between positive and negative? Of course, no. Between 42 and 6, both are divided by 6. When I choose the common number, I choose the GCD, the greatest common factor between the numbers. Do I have a common variable? Of course, no, since in 42 I have no variables. So I take as common 6. I write 6 and I open parentheses. I say 42 divided by 6 is 7. Minus 6x divided by 6 is minus x and I close parentheses. Now, the second example, a equal to x minus ax. Is there any common between the signs? No. Here the number is 2, here the number is 1. Of course, no common. Between x and ax, there is a common, which is x. So I divide each term by x. 2x divided by x is 2, minus ax divided by x is minus a. Now, b equal 35a minus 7b. Positive and negative, no common. 35 and 7 both are divided by 7. A and B, no common. So I take 7 and I open parentheses. 35a divided by 7 is 5a, minus 7b divided by 7, 7 cancels 7, so I get minus b. Now, 2a cubed plus 3a squared. Positive and positive, I don't take the positive sign because I don't write it. Between 2 and 3, no common. Between a cube and a square, I take the variable with the least exponent or the exponent which is less. So I take a squared and I open parentheses. 2a cubed divided by a squared, 2 divided by 1 is 2, and a cubed divided by a squared, I keep the base a and I subtract exponents. 3 minus 2 is 1, so I write a. Positive 3a squared divided by a squared cancels a squared since they have same base, same exponent, and I'm kept with positive 3. Now, we continue with f. In f, I have 3 terms, so I should find a common between the 3. Between positive, positive, and negative, no common. Between 5, 3, and 2, no common. between a squared b, and a squared c, so we have a common a squared, and I open parentheses. 5a squared divided by a squared is 5. Positive 3a squared b divided by a squared is positive 3b. Negative 2a squared c divided by a squared is negative 2c. Now I move down here. 21a squared y minus 14ay squared. Between positive and negative, no common. Between 21 and 14, both are divided by 7. Between a squared and a, I take the common with the least exponent, so I take a. Between y and y squared, I take y, so the common is 7ay. I start dividing the first term by the common factor. 21 by 7 is a 3, a squared by a is a, and y by y, they cancel each other's. Negative 14ay squared by 7ay. Negative by positive is negative. 14 by 7 is 2. A by a, they cancel each other's. Y squared by y, I get y. The last one here, also we have 3 terms, so we should find a common factor between the 3 terms. Positive, positive, and positive. Of course, positive is common. 24, 8, and 16. We can see that the 24, 8, and 16 are divisible by 2, are divisible by 4, are divisible by 8. So I take the greatest divisible, which is 8. A cubed, a squared, and a, so I take 8a. Also, I divide each term by the common, so I get this answer. If you look at all the answers we got, so we have a monomial multiplied by a binomial, a monomial multiplied by a binomial. They are written, my answer is written as a product of 2 things. Now, the common factor between the terms might be also a binomial. A equal A into 2A minus 3 minus 3 into 2A minus 3. Between A and minus 3, there's no common. But we can see that in the first term, 2A minus 3, the same as 2A minus 3. So this is a binomial and this is a binomial. So I take 2A minus 3 as common and I divide each term by 2A minus 3. Binomial 2A minus 3 cancels binomial 2A minus 3, so I'm kept with A. As you can see, I write my answer between brackets. Also, minus 3 into 2A minus 3, I divided by 2A minus 3, and I get minus 3. After that, I write my answer between parentheses. If you look at the answer, also we have a product of a binomial by a binomial. So this is factorized form. Also here you have 4 examples. You can solve these examples to get the answer. Also here, we are talking about factorization. The second form of factorization is to factorize using an algebraic expression or remarkable identities. So if I'm given an expanded form with the 3 terms and all the signs are positive, I don't have a common factor between the terms. So I directly say we should see if we can use the remarkable identity 1. So I check, we have 3 terms, all positive. So to write this expanded form in factorized form, we write a plus b, all of it squared. What's a? It is the root of a squared. What's b? It is the root of b squared. To know the sign inside here, we look at the sign of the second term. If it's positive, I write here positive. If it's negative, I write here negative. Now, if I have 2 terms, a squared minus b squared. So this is written as a minus b into a plus b, the root of a minus the root of b, and the root of a plus the root of b, or the inverse. A plus b into a minus b, it's the same concept. Let's do exercise. X squared plus 6x plus 9. First, I start. How many terms do we have? 3. Is there any common between the 3 terms? Not between the first 2 or the second and the third, between the 3. No. So you refactorize it using remarkable identity. Since the second term is positive and it is a 3 terms, so either remarkable identity 1 or 2. Since here we have a positive term, so it's remarkable identity 1. So I write parentheses, all of it squared, and inside I have a plus. What's the root of a squared, which is x squared? It's x. The root of b squared, which is 9, is 3. X squared plus 10x plus 25. Also, it's written factorized using remarkable identity 1, which is a plus b, all of it squared. A squared is x squared, so a is x. The second term is positive, so I write plus. B squared is 25, its root is 5, so I write x plus 5, all of it squared. 4x squared plus 28x plus 49. A squared is 4x squared, so I get the root of 4 and the root of x squared. The root of 4 is 2, the root of x squared is x, so I have 2x. Since this is positive, so I write positive in between. 49 is b squared. What's the root of 49? It's 7, so I write 2x plus 7, all of it squared. So as you can see, the second term is only used to know the sign between the terms in the remarkable identity. X squared minus 8x plus 16. Also, we have 3 terms, no common factor. Since the second term is negative, so we use remarkable identity 2. A minus b, all of it squared. A is x squared, its root is x. B squared is 16, its root is 4, so I get x minus 4, all of it squared. Sorry. 25x squared minus 30x plus 9. Also, since the second, we have 3 terms, no common between them, so we use the one of the remarkable identities 1 or 2. Since the second term is negative, so we use remarkable identity 2, which is a minus b, all of it squared. A squared is 25x squared, root of 25 is 5, root of x squared is x, so a is 5x. Minus b squared is 9, so b is 3. So I get 5x minus 3, all of it squared. X squared minus 4. Here I have 2 terms, no common in between, so we use remarkable identity 3. A squared minus b squared. So I need a plus b into a minus b. The root of x squared is x. The root of b squared is 2. So I write x minus 2 into x plus 2. 9x squared minus 25. A squared is 9x squared, its root is 3x. B squared is 25, its root is 5. So I write a minus b into a plus b. So 3x minus 5 into 3x plus 5, or 3x plus 5 into 3x minus 5. Now the first term is x minus 2, all of it squared. It's a binomial. The second term is 9. So I need the root of x minus 3 squared, which is binomial x minus 2. The root of 9 is 3. So I write a bracket, x minus 2 minus 3 into x minus 2 plus 3. This is the root of the first term minus the root of the second, the root of the first plus the root of the second. Now I should get rid of the first bracket. I write everything between parentheses. So I write x minus 2 minus 3, x minus 2 plus 3. Now I calculate the first term. X minus 2 minus 3 is minus 5. X minus 2 plus 3 is plus 1. So I get x minus 5 into x plus 1. As you can see, here we have 2 binomials multiplied together. Here also we have 2 binomials multiplied together. Why? Because x minus 4, all of it squared, is x minus 4 into x minus 4. This is x plus 5 into x plus 5. So all these are factorized forms. The last one also, we have 2 terms. The first term is 4 into x minus 5, all of it squared, minus the second term 9 into 2x minus 1, all of it squared. Since we have 2 terms, no common between, we solve it using remarkable identity 3. A squared minus B squared. A squared is 4 into x minus 5, all of it squared. So I get the root of 4 and the root of the binomial. So it is 2 into x minus 5. The root of 9 is a 3. The root of the binomial is 2x minus 1. So 3 into 2x minus 1. So now I write 2 into x minus 5 plus 3 into 2x minus 1. So I write a plus. Now I write the same but a minus in between. Now I get rid of the first bracket, I put them between parentheses. Also the second bracket, I put them between parentheses. Everything inside the parentheses, x minus 5 is multiplied by 2. Everything here is multiplied by positive 3. Now I calculate the first parenthesis and the second parenthesis, the like terms together. So I get 8x minus 13 into minus 4x minus 7. Also, this is factorized form. This was our lesson for this week, and our lesson is about factorization of an algebraic expression using common term and remarkable identities. As usual, please watch the video well, and if you have any question, ask me. Thank you.